The question asks, which is the Bronsted-Lowry acid? Well, remember that a Bronsted-Lowry acid donates a proton. I would first find the conjugate acid-base pairs. So this is a conjugate acid-base pair because it only differs by one proton. If you take NH3 and you add an H plus to it, you'll have NH4 plus. Conversely, if you take NH4 plus and you take away a proton, you'll have NH3. The other conjugate acid-base pair is H2O and H3O plus because, again, do you see how this has an extra proton and this is missing a proton? So now that you've identified your conjugate acid-base pairs, now you just need to decide which is the acid and which is the base. Well, an acid donates. Do you see how the NH4 plus donated? It no longer has a proton. So this is the acid. Where did it donate the proton to? It donated the proton to the H2O. So the H2O accepted the proton. That's the definition of a Bronsted-Lowry base. Then, to do this side, by definition, if it's on the product side, we call them conjugates. So this is going to be the conjugate, well, it donated. Do you see how it is going to lose a proton? So this must be a conjugate acid, because an acid donates a proton. This must be, therefore, the conjugate base, because it is all ready to accept a proton. So the things you do is, one, ID conjugate acid-base pairs. And then second, remember the definition of Bronsted-Lowry acids and bases. So acids always donate, bases always accept, and then remember that the conjugates are just always on the product side. I hope that helped. Come to office hours and ask your specific questions. I've noticed that different students get stuck in different places, and sometimes it's hard to ask those questions via email. Hope this helps.